Well,
Happy
hello.
Thursday, everybody.
Yes. Welcome to another episode of Cloud Foundry Weekly.
We are 7 minutes late, and I would love to give y'all a good excuse for that, but there's not. Nick was distracted by G-Chat. We were making jokes and having fun, and then we were like, oh, crap, we're late.
Yeah. We didn't have Deshaun and yelling at us in pre-chat to say, hey, I'm here. Where are you guys? So, Deshaun, I don't know what's going on.
I wonder if he even realized how critical he is to our show, not only, helping get us started, but keeping us on time. I mean, he's kind of like Mama Bear, making sure that we're doing our chores.
Yes. And I think we would be lost without him.
Yep.
I sure would be. Let me tell you that.
Yep.
I get lost in my thoughts pretty quickly here. Yeah. So what's going on with you, Nikki? It's another week. What's new with you?
Been busy, just trying to keep up with everything. We're going to be doing a talk at AWS AI Federal Conference in DC next week. So that's out there. If you're part of the government space and you're going to be going to the AWS conference, come out and see us. We're going to be doing a code talk with AWS themselves. So what can Coder bring to the security aspect? So that should be a lot of fun. And then we've got Commit Your Code the week after that. So big shout out to Dan Vega and Josh Long. They're going to be at Commit Your Code, I believe. So looking forward to catching up with those guys.
Is Commit Your Code like a community type of conference, or is that your own conference, or what's going on there?
It's not ours. It's a separate conference, but we're going to have, I know that Dan and Josh are going to be out there. They're going to be talking to all things Java. Coder is going to be out there talking about how we can make your dev environments better. So I won't be doing a talk myself at Commit Your Code, but I'll be there. I'll be looking for people I know, looking to have conversations. How about you? Anything upcoming?
Just upcoming would be Cloud Foundry Day Europe in October. So if you're, it's gonna be a great show. I advise you, if you don't already have tickets, get your tickets now, because they tend to sell out, especially in the European space. Very popular. So make sure you get your tickets. They're pretty cheap. It's like €50, so it's not like a whole lot of money. But yeah, come check out all the new stuff in the Cloud Foundry community.
I am so sad I'm going to miss that. That is a fun conference to attend. If you have any interest whatsoever in Cloud Foundry, this is somewhere where you got to go. A lot of people that have been doing this for a very long time. We got some new people that are coming in and just learning about it. Great way to learn, great way to network. I'm going to be sad I'm missing that one. You're doing a show there live, right?
Yeah. So we have a show lined up. I'm still working on the guest list. And if you're watching and you want to talk with us or be on the get, because we've kind of got this unspoken format now with the Cloud Foundry days, where the Cloud Foundry Weekly show kind of closes out the show, right? We're the last show. We're like this community panel, and we get to absorb all the day and then kind of talk off that and other things about what we see. So it's worked out. I think we're 3 for 3 now in the past 3 Cloud Foundry days. So this will be our 4th, and this will be our first without Nikki. I'm still sad, but if you change your mind, get your ticket to Frankfurt and get out there. But yeah,
I won't be able to make it. I mean, we might try to see. Maybe there's some weird magic that we could do where I might be able to join virtually. But I don't think. I think that's going to be way too much for our minds to try to wrap our heads around. We're just now figuring out how to do the live show, much less add in a virtual participant. So,
yes, very much so.
Abhishek, can you ask Vega what I can do to get a spring T-shirt? Well, I'll bring it up to him. I absolutely will.
Yeah.
If not, I think I've still got some extra. Real quick, Abhishek, throw in the chat what size you are. I think I got some extras. Maybe if I've got an extra, I'll bring you one myself. That'd be fun.
Very cool.
I mean, I'm not related to Spring anymore, but
hey, you got swag and swag, right? Yeah, spring is spring and swag is swag. So you put those two together.
That's right.
Even better, right?
Now, I hear you got a new baby.
Oh yeah. Yes. Yeah. So I've converted over to the M4 Max lifestyle, and I'm actually gonna have to drop and relaunch StreamYard at some point, because I'm getting I was getting ready to do my screen share, and I was like, whoopsies, I forgot this. It hasn't been done yet on this Mac. So I got to do the whole permission song and dance here eventually, but not quite yet. But yeah, it just, I guess the biggest thing I can, speak to it is I compiled a Java app earlier today, and the Maven compile was just like light speed.
Mm-hmm.
I was just blown away about the amount of just. I mean, I guess I fully regret not doing this sooner, because I was still running on an i9 MacBook Pro from circa 2019. And man, these M series processors, wow, they're fast, and they're cool, and the battery life is like it's pretty solid.
I mean, I don't want to say I told you so, but
yeah, I know, but
now everybody in the audience should know you're seeing Nick, the on-air personality, right now. When we were in the green room and he was talking about building this and the Maven compile, his arms were flying around.
Yeah,
and
like
he was
just
getting
like
all
light
excited.
speed. Like I was just like, I didn't know it could happen that fast. I usually just watch like each line paint individually, but it was just like 100 lines immediately. It was just wow. Anyway, I'm sure like there's that DHH guy out there on Twitter who's always talking about like compile times of code and like different machines. So like I'm just catching up to the 2025 and these crazy Apple chips. And not to mention the 128 gig of shared unified memory for local LLM experimentation. It's pretty top notch too. So
yeah, Nick's still out there, compiling like it's 2018. He doesn't know that we've got all this new stuff. And it reminds me, you remember that commercial, the Campbell's chicken soup commercial, where the bowl gets to the end and the little kid's like, I didn't know this had chicken in it. This was Nick. I didn't know you could compile this fast.
Yeah. It was amazing. Anyway, that's kind of where my life is right now. Just how fast, and it's like, and it's sometimes you get like a new phone, right? And like I'll occasionally run 3 to 4 years on my phone, and then you get a new phone, you're like, oh my god, everything's faster. Like, well, it's this times like 100, I think. But yes.
All right. Well, you started this. Today's going to be a fun show, guys. We don't have anything real specific we're going to talk about, so it's going to be a little bit of a banter show. But Nick just got me fired up on something about a new phone. I'm an Apple guy. I'm in the ecosystem. I love Apple, but I'm getting a little pissy with Apple and their iPhones. There's not a whole lot of change. They haven't done anything real new in a while.
Well, did you not see the iPhone Air launch announcement?
Oh,
okay.
Did you see the same fall and they made it smaller?
Well, it's revolutionary. I don't know.
We improved. Now they did do some things, right? They're going 120 hertz across the platform. That's good if you're a gamer. It's going to make scrolling a little bit better. They bumped the camera a little bit. They did some other things with the variable refresh rates to hold your batteries. But come on, it's the phone hasn't really changed since like the 10. I mean, really. For the first time, I was actually, it angers me to say this, I was thinking about going to an Android phone. I really like the Fold. They say they're coming out with one next year. I'm going to hold on one more year, but come on, Apple, get your stuff together. You're supposed to be the innovative company. Be innovative. See, Nick's already worried that now we're going to get attacked by the full might of Apple. No, but hey, this is what we talk about.
Apple versus Android. Hey. I mean, I like my Apple lifestyle. It's easy, just like I like my Cloud Foundry lifestyle. It's very easy as well. So, Apple
AirPod Pros, one of the greatest, in-ear sets I've ever seen. I love those. I love the MacBooks. The minis keep growing. iPad's getting better. The phone hasn't effing changed since iPhone. It
just works. I don't know.
It does just work. I got to give that credit. Yep. All right, I'm done.
All right.
See, this is what happens when you never know when I'm gonna get pissed.
No, it's all good. It's all good. All right, so let's talk. And this show's gonna kind of be a maybe say unofficial part 2 of last show.
Okay.
Right. So we're talking, open source models, large language models, all the AI stuff, right? But GPT-OSS was released by OpenAI, and that was like their I think first true open source model since, open weights, whatever. That's the actual proper term. Since like 2019, I think, if I remember correctly. Maybe the GPT-2 was the last one to be launched like that. But that's really kind of been interesting in this AI enterprise space, right? Where now we have a very Apache 2 based model licensed from a the kind of the brand name of AI, right? So that, that's really piqued a lot of interest for a lot of our customers. So I've been doing a lot of testing, and they've done a lot of things. It's an interesting model. It's not the highest performing model, but it's a very well performing model, and it's got some interesting things where it's from a sizing perspective, it's size to performance is actually pretty good. So I kind of wanted to jump into like different things that I've seen about running it, obviously within the Tanzu platform space / Cloud Foundry space. But if you're watching this and you just, are generally interested, some of this should rub off too on you without going full Cloud Foundry land or whatever. But that's kind of the thought for today. And some of these principles that we talked about and the issues that we had in the last show, if you haven't seen the last show, we talked about kind of like debugging LLMs, and Cote was on, and we went all kind of cross of like how to form an AI council to how to get models in and get through your security, and then like how to size them and what to do on some of the hardware. We'll see a lot of these themes today in the show as well. So,
well, let's start it off, because you mentioned too. Let's make sure everybody's on the same page here. So, open source versus open weight. I'll give my explanation. You tell me where I'm right, where I'm wrong. So, open source, full transparency. We show you the parameters. We show you the training code. We show you the data that was used. That's open source. Open weights is we give you the parameters, we give you everything that's been trained, but we don't show you the code or the data, correct?
Yeah. We're not going to give you the data set or what we use or how we, ran the data set through that code. So yeah, I think that is most accurate, at least to my understanding of it. Now, someone in the, data scientist AI space might have a better answer, but I think that's good enough for us.
Do you know, because I don't, I'm going to be very transparent. I don't know. What does that mean to the end user if they don't have the training code, training data? I imagine it lets them do a little bit more fine tuning, make it a little bit easier to fine tune. I don't know.
Yeah. Some of it's too, it's just like how, like the origins of the model, right? It's more of like, where was this, like, what was this training set based on? Like, what was this data based on? So like explaining some of the behavior of the model is from my understanding. Now, like obviously fine tuning, they can do that with like open weights and, the Apache 2 license is pretty clear there. So there's already been some fine tunes of it. There's some concerns, or some people have complained about like how it's got some safety, like censorship things as well, where they're trying to like, take those out. And, there's always a wide range of things people will do to some of these models to fine tune them, modify them to their needs. But overall, I feel like it's a pretty good fit for the corporate enterprise in terms of we need a model that's performant enough that can run on, not a huge amount of hardware, that we can run in our four walls or behind our, our VPC, without sending, we have all these customers have all these use cases that just simply cannot go to a SaaS based model provider, right? Like, maybe one day, but like in the short term, lots of data, lots of use cases that can't really go to public cloud, and that principle really is only amplified across, can't go to a public model provider / shared large language model type of thing. And I do feel like we'll probably see more and more of this, where at least I hope from the the United States based AI companies, where they realize that this is happening and they need to release some of these models to like kind of keep their brand name up, so to speak. And yeah, they're in the business of selling tokens, so they're not going to be releasing their best and brightest cutting edge models, right? They're gonna save those for some cost. Try to make some profit with all this money they're burning left and right, and all these companies they're buying hardware from. Thanks, by the way. And really liking that stock situation, but yeah, can't complain. OpenAI. Anyway, yeah. So that's kind of where we're at. So
okay,
I've done a lot of talking. I need to share my screen, but in order to do that, I think I'm gonna have to step out for like a hot minute. So I don't know, Nikki, if you want to do like a commercial for Coder while I'm out, or something. I don't know. Entertain our audience while I'm gone for just a little bit. Are you okay with that?
Here's the Macarena coming up.
Yeah, and I'll come back and everything will be on fire. All right. All right, let me do this song and dance here. Share screen. Yes. Oh. Well, maybe I can do this. Maybe I lied.
It's just going to work.
Oh no, open system settings. All right, I think I'm going to drop here now.
All right, then we'll be here waiting for you. Be quick about it.
All right.
So as we're waiting, when everybody comes back, those that are listening, we've got the audience out there. Everybody make sure you make fun of Nick for taking so long to get a new computer. You should have seen the thing that he was running around with. It was frankly embarrassing. So everybody that's out there, get in the chat, make fun of him. So when he comes back, he sees all these things. I can throw up a bunch of insults. I can throw up a bunch of making fun of him. And we'll do that. Now, on the open weights model, having the parameters, it is my understanding that this does, allow for a little bit more fine tuning. You can jump in, you can do the fine tuning that you need to do there. So that's something that's going to be very important. And it is a little bit lighter weight towards Nick's statement. OpenAI, Claude, he's back. Never mind. All right. I told everybody to make fun of you, but not a single person's done it yet.
That's fair. Thanks.
And I know Keith's out there. I'd expected Keith to at least say something, but you let me down, Keith. All right.
Hey.
And I'm not used to being on the left. Now you've screwed me all up.
How do we do that? Can we?
I don't know.
Can we?
We'll do.
Oh,
here we go. Now I'm back where I'm supposed to be.
Science.
That's
I don't know. All right,
welcome to on live testing.
Yes. Yeah. All right. Of course. Now I had all my windows prepped and ready to go, but it killed all of my Chrome. And now, my response time. Am I back? Am I okay?
No. He was making your response time because you got a new laptop. I was telling everybody to send messages to make fun of you for taking so long and carrying around something from 2018.
I apologize.
Corporate refresh cycles, they hurt the ones you love.
Your soul is hurting the most.
And by the way, thank you, Abhishek. You've been extremely vocal on the chat for the last 4 or so episodes. It's much appreciated. Hopefully you're getting something good out of this while we watch Nick bring up his browser windows and screens. And I've got this weird cowlick thing going on. Can you tell what side I sleep on at night? All right.
Your crooked beard.
My crooked beard.
Okay. Alrighty. I'm ready to roll. All right. So let's first talk about models. And this model, we'll bring up the Ollama library just because I don't know, it's easiest, right? So GPT-OSS is released. It's a little bit of a month ago now. I've been wanting to do this episode for quite some time, actually. But we're gonna run this model in like at least 3 different ways. So I want to run it on a CPU. I want to run it on GPUs, and then I want to run it on more or different. I want to use Ollama for CPU and GPU inference, and then I want to use VLM for GPU inference as well. So we'll kind of see those differences and talk about some of those use cases and what's going on there. Now, GPT-OSS launched some new interesting things. Let's see if it says it here on this. Most interesting, they released this new quantization format called MXFP4. So it's kind of like natively quantized so you're not going to see all these different like Q8s and all this stuff around. And it's also an MOE model. So there's a 20 billion format and 120 billion format, but the 20 billion is, let's see, where do they have?
So let's go ahead and explain the mixture of experts for people that are out there that don't know. What is MOE?
Yeah, so it's essentially we're going to take let me bring up Hugging Face. So I was gonna dive into that, but I didn't see it on their page there. So if we go to the Hugging Face version of this, you'll have a model. Let's say like that 20 billion parameter model, right? The mixture of experts means that only a certain subset of them will be activated. That means it's going to run like at the inference speeds of a much smaller model, but have all these additional layers. So it's not, let's just say, it's a much more intelligent model versus just having the 2 or 3 billion active parameters only, so to speak. So
it's specialization within the model itself. So there's going to be, you got, mixture of experts. You got a bunch of little specialists that are going to be in there.
Yeah.
And then you're going to have the model's going to do some routing on who it's going to call, which expert it's going to call for what request.
Yes. And additionally too, I guess like GPT-OSS does this pretty well. Like the Qwen 3 family does this pretty well as well. I think DeepSeek to some degree too. It's where you'll have this MOE layer done. Like there was an architecture diagram that someone broke down the differences between like Qwen 3 and GPT-OSS and how they did the mixture of experts. Like there's like very low level technical detail, and I'll have to, maybe if I have the time to find that. It's interesting just like to look at and kind of absorb, so to speak. So like now, everybody kind of does it a little bit differently, but yes, go ahead.
Is there anything that you have to do to take advantage of this, or is it just inherent into the model?
So it's usually inherent into the model. Like the model is either MOE or not, from what I understand. And there's also potentially not all of them do the level or the activation level, so to speak, or not. So where is this? Oh, yeah, okay, here. Sorry. So like the 120 billion parameter model. Let me zoom in. So this is on the Hugging Face page from GPT or OpenAI. It has 117 parameters with 5.1 billion active parameters. Okay, so that means you really only, if we're doing fast, talking about inference speed, that 5.1 billion active parameters are only the ones that are actually going to be really like akin to wanting a GPU. The rest of the 100 and some are gonna kind of be like CPU friendly, so to speak. And similarly to the 20 billion, we've got 21 billion active with 21 billion total with 3.6 active billion parameters. So that's kind of, when we see these lower active billion parameters, like then we're starting to get into like, maybe we can kind of get away with doing some CPU work as well and see where we get there. And we'll kind of see how these perform and see what we can do and kind of go from there.
Nice. Okay.
So I've went in cooking show format, went and deployed a few models already here. I've got 2 of the 3 that I wanted to deploy done, and then we'll get to the third if time allows. Otherwise, I already have it somewhere else. I'll just pull up that foundation and we can talk about it. So this first model, so we have Ollama and VLM within the platform. We're looking at just straight pulling from Ollama. So I'm using this exact tag that's in the Ollama library here, right? So GPT-OSS 20B, right? So that that the tile is going to pull that tag. I've given it a handle to kind of tag it as CPU. We'll use that a little bit later. I've got chat and tools enabled for it. I've got to keep alive -1. That means once it loads, don't destage, because this is a app web service here. I don't want you destaging from memory. Number of parallel requests, I just kept that to 1 to help keep some of the things down. And then context length is the full context length. So it's 131.072 is equal to 128K tokens. And the other 2 things that we're going to talk about here is KV cache type. So because we're using this new quantization format, the whatever it was, the MX FP4 or whatever, it doesn't really support quantizing the cache, the KV cache. So we're just going to leave that to F16. And a lot of our other models and examples, we don't leave that to F16. So that's something to keep in mind. And then we're going to keep flash attention up because that's something that's useful for making the best use of like your VRAM and RAM to organize the model in a way that makes sense, so to speak. Optimized for memory usage and faster inference. So that's essentially all we really need here for this model. I'm just pulling directly from the Ollama library. I'm not worried about an offline model, and I'm telling you what AZ to use. And I've got a CPU large VM, so it's a 16 core, 65 gig of RAM. So we can let's just that's already been deployed. It's ready to roll. And I've went ahead and pushed some demo apps to the platform here. And I just wanted to kind of do a compare and contrast, so to speak.
Love demo apps.
Yes. So All right, so we have Tanzu Chat, and this is just a version of Tanzu Chat. And we're going to say we're going to bind this to a CPU. So we're going to go services. We're going to add a new service. And I'm going to select the Tanzu Chat GPT-OSS 20 billion CPU model service. I'm going to call that the same and click create. And then we'll see where this goes. Okay, that's created. Let's go to view app. Yes, this cert needs updated in this one. I feel like I am zooming in ginormous.
Hello. Well, it's readable. It's not too huge. You're doing well.
Okay. Hello. All right. Did it bind? Oh, I need to restart my app. This is a rookie mistake.
Son of a.
Yeah. So be if you haven't seen this before, we're binding this model that we provisioned into the, we're injecting the API and credentials into the app and under VCAP services, and we need to restart the app to pick up said services in the Spring profile. All right, so that's ready to run. All right, now we have a model. Nothing else is available. We should say hello, and we'll see where we get back. And I haven't tested this CPU inference yet. Hello, how can I assist you today? Oh, that was pretty decent. What is the current time? We'll see what it comes back with this. Maybe I'm a little. Look, that feels okay. I want to. All right, I want to go into the actual VM here because I haven't drilled too much into this directly here. I want to see this because this is actually running better, much better than I expected. I want to keep that up. Clear. All right. We'll make the world's largest terminal session. SSH.
You download Magnet or something? Man, you're getting good with that window placement.
Rectangle is my window.
Rectangle?
Yeah.
I'm a Magnet guy.
I haven't tried that. I've also saw that. So I'll have to. Why can I not? All right. Well, I'm going to use this one because I don't know. It's not like, doesn't like. All right. So I'm listing the VMs.
If you can blow it up.
How about this? I'll make it like there.
Nah, that didn't do really any good. It's still
well, I'm losing it as I zoom.
Gotcha. That's good. That's good. You're more than good now.
Okay, let me back up. It's a challenge, right? How do I do this without making it crazy? All right, so I think it's this one, CPU large. Okay, yeah. So we're gonna SSH into this VM. I'm just curious about performance as we do this. I don't know. Do my friend H-Top. All right. Yeah, we got 16 CPUs. We're only using 16.7 gigs of RAM, and this is running on a Cascade Lake system. So it's what you will have at a bare minimum in your data center. That generation is actively being purged from e-wasted because it's just it's like 5-6 years old now, so it's coming up on the long tooth of that hardware. Now that is a pretty good question. Sorry, so I asked a question, like wait a little bit. It wasn't like immediate response time, but I don't have a tokens per second count on here, but I feel like it's a pretty decent tokens per second considering I'm running on a relatively old enterprise grade CPU right now. Now let's do some MCP stuff here because I want to like do the time check now. So let's see. That's another thing too, is how models react or how they handle tool calls. Because not all models, and not even the same model on the same inference on different inference providers are the same, so to speak. So do I have a user provided service here? I think I need to do that. Tanzu chat services. I don't. I need to make one.
Now, this is not the same graph that you used in other things to show where the memory was spiking, where the CPU was spiking. I remember you had like a line chart before.
So you may be remembering NV Top. which is the GPU based version of this. So this is
Okay.
just HTOP, right? So like,
Gotcha.
it's just a little prettier version of just your normal top situation. All right, so I got a time MCP server bound. I think that's working. So we'll. I really need I don't know. This is. Maybe I'm gonna zoom out this a little. I can't see at all. All right, services. Let's do bind service now. All right, we're gonna bind the MCP. Okay, maybe. If I find the bind button here, it's oh boy. I gotta zoom out here a little on this. There you go. Bind. And then we'll restart. I've got too much zoom, but yeah. So the next thing is after we restart this, I want to see how well we can do this, because if we can do like basic chat and MCP calls on this model is running quite well on a CPU, right? So I hear time after time, well, let's see what it says now. All right, I have my time. So yeah, I can get the current time, right? So what I'm really doing with this is, right, because that these models don't know about the current time, current data, current anything unless you hook them up to agents or MCP servers.
Mm-hmm.
That's kind of what we're doing here. We're giving it this time server here. So now when I say what's the current time is, it should like go do something. And now it's it's thinking a lot more. But the current date is what is it? Yeah, it's September 11th. Yeah. And UTC. All right. What is it? What is the current? And I'm just thinking a little bit more here, but Central Daylight Time. Okay. Well, yeah, that's another thing too. Is like, so this is close. I don't this one model, right? Cincinnati is actually in Eastern Time, so I don't know what specifically happens. Like it's dead on, but it's confused where Cincinnati is. So that's what I've seen every now and then randomly where this will happen. But it is talking to the server. It's getting the current time. It's just confused on what the time zone is. Cincinnati is. So I mean, I think on a short test here, we're getting some valid responses, like pretty easy to use. And I could see actually making some pretty, maybe even going to production on some of these smaller type inference workloads. And, again, I'm getting this level of performance on a relatively old, it's a Cascade Lake CPU. If you're on a new modern either new AMD EPYC system or Intel based system, you're going to be running much faster DRAM speeds. You're going to have you're going to have processors that are more optimized for this type of workload. Like if you're on the Intel road or train, you're going to get the Intel AMX extensions, which will help out this type of math happening behind the scenes. So again, a pretty decent demo just from CPUs alone.
No, we did see it. It did max out the CPUs that you've got. And to Abhishek's point, right? He said when you're calling the tools, when you're calling the MCP server, it's taking a lot of time. But that's a hardware issue right now. That's not a model issue. Now, I would argue that the model is not given a good first showing, not knowing where Cincinnati's at. That should be something that should be. Now, is that an impact from the MCP, or is that an impact from the model?
So I don't know what's happening there. I wonder if it could be something with the time server. It's showing like that something is wrong with the time server itself.
Well, let's try it. Just say, no, you're wrong. Cincinnati's Eastern. Why do you think it's Central Time? Central.
You are wrong. Why? Cincinnati is in, I guess it's Eastern Daylight Time now. I never know EST.
I don't even remember.
Please correct.
And ask it to, I would ask it, why do you think it's Central?
Why did you get this wrong?
There you go.
Let's get angry with it.
Yeah.
Exclamation. No, this is we'll see what it says. I haven't gotten too feisty with GPT-OSS. So sometimes they'll get feisty with you back.
Well, just remember this when they take over the world, that they're going to remember you were mean to it.
Yeah, and so it does take some time, but at the same time, though, we see time and time again a lot of our customer base. Uh, okay, all right. Okay, all right. Yeah, so it fixed it. It didn't get the current time, so I apologize for the error. It was simple. Yeah, so yeah, it was very polite. I reprimanded it, and it cleaned up its mess. So it is in the 1 p.m. Eastern
It's
Daylight
one of
Time.
the things I love about, and it doesn't matter which model you use. It's one of the
Mhm.
things I love about AI is when you find mistakes or it goes and it hallucinates and it makes stuff up, and you're like, don't do that. My
Mhm.
bad. I shouldn't have done that. I promise not to. It's like you just had a interview. It's like talking to your kid. You're talking to your kid, and you asked them if they've done with all their history studying, and they lie to you, and they say, "Yeah, I did all my studying for my history test."
Mhm.
Well, your book is still in my car. Oh yeah, you caught me. My bad.
Yeah.
I
Yeah.
enjoy that about AI. Now there's times I want to punch it in the mouth, but I enjoy that portion. At least it's very polite and it didn't hold nothing back.
And it could be too something where something in its context is out
Mhm.
of whack. Now, Corby Page wrote this app and wrote this MCP server, and he's on Central Time. So I wonder if somehow,
Mhm.
somewhere,
Good point.
there's something in this context where like it just wants to default to Central Daylight Time. But
Right.
yeah, I'm curious. I haven't looked into the code in a while, so I'll have to give it a check to see if it's the model, if it's the MCP server, it's whatever. But yeah,
Yep.
um,
And
yes,
yes,
Oren,
Oren, he did.
yes,
Oh, you got it.
I'll bring up my vCenter to I can show the correlation on vCenter. There's no GPUs attached, and I could show the HTOP, whatever I wanted to say. I could show ESXi top too, but that seems a bit excessive. So, and it's been a long time since I've used that, so I'd have to like figure out how to do that again.
So while you're doing that, use cases here. This is just another model that somebody can use.
Yeah.
Yep.
I mean, well, it's a good model that one. If we go back to that chart from like example customer, here's all these open source models, and like they're all denied
Right.
except for like these two, right?
Mhm.
Right. Like most cases, like a lot of enterprises are going to have issue with it unless it's actually a truly Apache 2 license model, right? There's no hidden gotchas. There's no like morality clauses. There's no like, come talk to us if you're X size of company, so we can actually work out a backroom deal. We're gonna pay you money, or vice versa type of thing. It's just Apache 2 license, like
Okay.
that's it, right? So that's why I think it's been very popular, and then of course too, it because of it's this mixture of experts with a subset parameter only active. That seems to be a very interesting use case as well. And it kind of Quen first really brought that on, at least where we a few episodes back we talked about the Quen 3 model where it had like 30 billion parameters, but only 3 were active. It's a similar flow here, just slightly different. So I think that's why it's pretty interesting. And then of course it's got the brand name of OpenAI, so a lot of people are excited about that as well. So
Yep. Well, and one more option, like you said, for people that have licensing concerns or anything like that. And I doubt, it's not the last. We're going to see a lot more. But I, to your point, I'm very happy to see that some of the big guys are considering how they're going to get this out there, how people can use it rather than just the paid. So not true open source, open weight, but that's pretty good.
all right, I gotta get my cloud ID out of this thing so I can show Oren how. All right, it's this 3F. All right. All right, so Oren, if you're watching, I'm zooming in here. I don't have any PCI devices attached. Here's the model. I can even I guess pull up the C model monitor. Where's the performance overview? Yeah, so we see our little CPU spikes, memory going in here. Yeah, I'll ask it one more time. But write me a joke. I don't know about Cloud Foundry. So we'll see that. Now I'm out of the. All right. So yeah, vertical scaling. So do we see another little spike on the CPU? Probably. It hasn't caught up yet, but that's what's going on. So again, we covered basic just CPU inference.
Mhm.
Yeah. Oh yes. I have a large HomeLab. If anyone hasn't seen this show, it's more like a home data center at this point. But and my power bill is something that I pay every month. I just don't look at it. So it is what it is. Yes. Okay. So all right, the lab is there. That's ready to go. All right. So what's next? So we got the bases covered on Llama. Yeah. Yeah. It's all because of my new laptop. Exactly. Yeah.
Probably a lot of that. It's probably going to be. We're probably going to see some benefits in the show simply because of that.
Yeah. Yeah. I already feel like I'm running more efficient. Oh, thanks. Oh, yeah.
I'm sleeping better, and my wife loves me again.
Yeah. All right, I'm gonna drop off stage here 1 second here while I do some password shenanigans. But we need to talk about our next steps. What is that?
Exactly, Keith. I was going to say, AKA Broadcom Cincinnati Data Center, but
no.
thought better about that and decided not to. I like US East 3 better.
Yeah, there's no tie into any Broadcom resources in my data center HomeLab at all. This is purely Coon Labs Inc. Incorporated. Anyway, nothing to see here, folks. Moving along. All right, so let's bring up our VLM model here because that's something to talk about. And something we talked about last show or last week was that VLM was like the performance king, right? And we'll go to there. We'll go to this top model, and then we're going to see some differences.
I'm going to add you back to stage because you removed yourself, so bringing you back in. There we go.
Thank you. All right. Thank you. All right. And now we're going to go back to your NV top here. Is this what you're looking for?
That is what I was looking for.
Yeah. All right. So this is running on 2 A4000 GPUs in PCI pass-through mode. And they're just kind of a run-of-the-mill old or pro workstation card that are decent from my eBay Scrapyard Wars find. And it is running on VLM, and VLM just likes to use every inch possible of resources you throw at it. So it's actually using Ray to split the model up. And it's basically maxing out these cards, just leaving just a little bit of wiggle room so we don't get an out of memory event when we start doing inference. So it's sitting there ready to go. We go to our services here. I don't have any models. I think empty. Hi. All right. So all right. Yay. Right. Now let's go bind the service and start asking questions. So I think we need to make a new service, if I remember correctly. Yeah.
Sure. Now, are you running the same thing on GPU? Is that what we're looking at?
Yeah, on VLM specifically. Yep. So, and then we'll look at the Llama GPU as well. So we'll add a service. We'll go to here, and then we're going to do this. And now it probably won't be as noticeable because the CPU model is actually performing pretty decently. Actually, much better than I expected it to, because it's been a long time since I've tested this on CPU only. All right, so now we got this. We're going to go back to my VLM. I'm going to bind, and we're going to bind to this. Bind. And all right, we'll go back to our app. VLM, okay. Let's refresh, maybe. Did it again. I'm just forgetting how to computer, Nikki. I got to restart the app once I bind the service.
You know what? Nobody's going to hold it against you. You're very excited. You got something new. It's going to take a little bit of that excitement to wear off, and then you'll get back into the groove of things. Everything's happening so fast, it's throwing off your game.
Yes. Oh, yeah. Deshaun's like messaging me like show today. I'm like on right now. Like on right now, right? We started the show talking about you, Deshaun, and all right. Hopefully, you got that.
Here's a question from Trevor. Any particular reason you chose to use VLM rather than Llama for the GPU version?
Yes, we're gonna get there.
So patience.
Foreshadowing, patience, right? Yeah. right, so let's just say hello. And it's going to take a little second to spin up. We'll see. Oh, does this break? Uh-oh.
Hey.
Hi.
There we go.
Well, that was weird. That first hit was weird. Okay. Yeah, so it was all right. Now, what did I say last? I was like, what is the current time? And it's gonna be like, hey, I don't know what's going on. Right. Interesting.
I'm gonna be honest. I'm not seeing a lot of difference here.
What? I don't know what's happening on this VLM server right now, but it's not supposed to be doing this. It's usually much faster. So that A or like that. Yes, I don't know what's going on here.
Because
maybe I just need to like warm its cache a little bit, but it's.
I'm gonna say that there we go. Okay, that's a little bit better. So say CPU kicked its ass last time.
Yeah, well, that's normally not the case, and typically you use VLM because of its ability to do performance like very fast, low latency inference. It can handle like multiple users at a time in a much more efficient way. Yeah, and it's having a little bit of a, I don't know what's going on. Maybe I need to restart this worker or something.
I know this has got nothing to do with GPUs, but look at that. I mean, it got a little snotty with you there. Hey, why don't you go look at a clock, Nick?
Yeah. See, yeah. Huh? Check your time.
Hey,
okay.
Why don't you take that bass out of your voice there?
What
chat
tools
model
do you have available? Oh, I did double question marks. It's gonna get it real angry with me now. Let's see. Yeah, now this isn't a great example because something's wrong with my VLM worker or something. But yeah, it's right now pretty fast. So it doesn't have any tools attached to it. It's just, like, here's what I can do, right? And we didn't bind the time server yet, so let's do that and we'll see what happens. And then restart. Now, based on my current testing, there's actually a current issue with VLM and GPT-OSS where tooling and function calling isn't quite 100% there yet because they introduced this new thing called like the Harmony chat template. Okay. So a lot of the inference engines are still like picking up the pieces and adding new things. So like these API calls probably aren't going to land. So let's see here. I have this ready to go. So now let's just, let's just go with it. What's the current time? Let's see what happens. It's going to probably tell me to go look at my watch again.
Yeah. Didn't I tell you to look at your watch last time, Nick?
Yeah. So now it's coming back. It doesn't. Yeah. So this version, this VLM, and I was checking like PRs this morning because I was trying to troubleshoot this. Apparently there's a fix for this that went into like the main channel or main repo, main branch, I guess that's the proper way, of VLM to fix some of these tool calling issues. Mm-hmm. But it hasn't they haven't cut a new release of VLM yet. So it hasn't rolled into a proper release of that. So if you're using VLM and GPT-OSS, you're gonna have your mileage may vary, especially if you're doing kind of like tool calling, function calling. So that's when I wanted to be that. Usually we use VLM for most throughput and lowest latency inference possible. Usually it's just stomps these models compared to like Ollama, even in GPU and VLM is much more efficient about using multiple GPUs in a amplified throughput, so to speak, way to some degree. Obviously, if you can fit everything in a single GPU, it'd still be the fastest, but the way it uses Ray and kind of does like the tensor parallelism is what they call it. It's a much more efficient flow than when Ollama uses multiple GPUs. It does not quite do that. And it's just, it can become problematic or slower. So if you have slower GPUs and you want to do multiple and you need to span across multiple GPUs to fit the model, you're going to have a much slower time, let's just say, on Ollama because it's not as efficient in the multi-GPU race, so to speak. Now, this whole test is a little bit skewed because that CPU was running so much better than I had this weird kind of cache hit thing going on, but that's kind of what's happening. Now I should be able to show, I think, the same model running on Llama, and I can see the tool call happen, because let me bring that up here. But that was kind of the gist of like, these are all like, same model, different inference engine. You can get completely like, oh, well, this is faster here, but like tool calls don't work at all. Like, well, that's a problem, right? Like, or Llama's a little bit slower, but it can do this. So it's just a little bit mix and match. And another thing too is that VLM has deprecated some of the older GPU types, or is in the process of deprecating. So if you have older cards, you're probably going to stick with Llama, just because VLM probably won't even work, or you'll get a lot of errors and you'll be sad and angry. And it's Llama is just an easier way to work with, so to speak.
Yep. And while you're doing that, look who finally decided to show up instead of sending you text messages and interrupting our show.
Welcome to the party, Deshaun.
Thanks, buddy.
We appreciate your business here.
What's your preference and why? Which one do you like, Llama versus VLLM? What is your preference and why?
I enjoy Llama in terms of less headaches, less matrices and things. But at the same time, if you get something running well on VLM, you're going to have a great time, right? Because it's like, Llama's good for like testing and like maybe small use cases. But if you say, hey, I want to take this web app that has like 10,000 users, right? And I want to have these chat requests going to a inference engine, you're going to want to use VLM, and you're going to probably need multiple VM workers to start handling that load type of thing.
Well, and there's a resource difference there as well. I think, I think Keith mentioned it up in the chat. VLLM is super resource hungry. Is that not true?
Oh yeah. It will, if you have the gear to run it, you're going to have a good time, but it is super resource hungry. It will just consume as much as possible to do all this like caching and thing to help out inferencing. And that's kind of what you saw. And maybe there's a few flags to set to like do like a clean cache or something. So maybe I need to set that flag to not get that random like a response back in that first call or whatever. But it woke up. It was a little lost for a second, but that's kind of what we're seeing.
You kind of got the Boston accent with that one. Hello.
Hey, what you want?
Yeah.
I'm just sitting over here, consuming all your power.
I'm computing here. Leave me alone.
Yeah. Models, whatever. Yeah.
By the way, I apologize to all the East Coast people where we just completely screwed up y'all's accents.
Technically, I'm on the East Coast still, so
it's Ohio, buddy. It's
not East Coast, but they're Eastern time zone. Not apparently to GPT-OSS though. Thanks for a sentence. Maybe no sense that I don't know we're gonna change time zones. I don't know.
Maybe it's I was gonna say maybe I would love to get rid of the time zones. Or not the time zones, but daylight savings time altogether. That way we don't have to ask those questions. Is it DST or is it?
Yeah, mountain time or whatever. Yeah. Okay. So all right. So we're in Llama. We're doing 20B. I'll zoom in here because you can't read it. Oh, wrong zoom. All right. Similar format. Use the same handle. And this is a different foundation, so I didn't quite do that. Chat tools. Keep alive -1. Great. And I'll write a little blog probably on this to be, so I'm not too crazy here. However, we'll notice the context length is much lower. Here, it's only 32,768. KV cache is the same. Flash attention. And what we're doing here is that I wanted to run this on a GPU. And early on, we were seeing issues with Llama calculating space needed, where like on a CPU, it's only going to use 16.7 gigs, but on this other model, like you try to do a GPU, it wants to use a lot more layers, so to speak, a lot more VRAM. So let's see what's going on in this model. Exit. All right. I need to go to this different foundation. All right. Sorry, my type. I was just trying to prime this. All right, so what's this? It does not like wrapping. All right, so here we go.
And this is the thing I love about Cloud Foundry and what they're doing with them, bringing the ability to bring models in and use those as services. We keep talking about the fourth cloud, which is private cloud.
Mhm.
This is you're bringing in, this is like Amazon Bedrock. This is like Vertex, but it's in your data center. You're still providing those models out. You're making them accessible. Now you can bring those cloud versions in as well, but you've got to do some of their private offerings. This gives you full control. This is another one of those things. I don't think we mentioned that enough, Nick, to say that again, we are replicating the public cloud experience in its entirety here, even with bringing in models now.
Yeah. You get the full paths, the full platform, everything ready to go. Can't complain.
Yep.
So to speak.
Frameworks, data services, AI. I mean, all of that is now fully contained, something that you can run on your private cloud, and you can replicate the same thing that people are getting from Amazon or Azure or Google. But you own it, you control it, and it's still extremely simple to manage.
Yes. I'm
concentrating.
I'm checking out a password here because I'm still don't have all my stuff synced over here yet, but I will get this here momentarily. Credentials off screen. I'm getting my UA admin password. So,
throw it up on screen. Ain't nobody
gonna man. I'm not going to put this one up on screen because theoretically it's on the internet if you know where to go. JK, don't try to hack me.
I was fixing to say I wouldn't have said that. Now everybody's going to be looking. All right.
Whee. All right. Okay, I'm back.
I will have a counseling session with Nick later about proper security and things not to say live on podcast. All my credentials are out there. You just got to know where to go look.
All right. Do I have services? Where did I do this? All right, I should have this staged already. And this doesn't really matter. I guess I just wanted to show the tool call working. I think this is it. Multi-model RAG should be okay. All right, so let's look into this plan. Yeah, because this one I set it up with a multi-model RAG. So it's going to be GPT-OSS. So, hey, let's do it. All right. And we'll see that spike on the GPU worker when we call it.
And while we're waiting, any questions out there? Happy to take them. As we've got Nick powering through.
Hey, I'm going to unbind this database service because the context of the MCP server and the database conflict with each other, at least on the time question. So just a pro tip there. When you get some more pull requests into that app so it can effectively balance out context requests. Yes. Okay. So yeah, we're gonna close the show here with just a quick demo. Hopefully it's working. And then I think the star of the show is going to be the CPU model here. Let's see. All right.
So far, I mean, it's subjective, but I felt it ran faster than your VLLM.
Hi. All right.
Hey.
Okay.
Whoa.
Hello. All right, so yeah, you can see this is on a Llama. This is on a single card. It has a lower context window set to fit it in that single card. However, if I probably ran it on the two cards that I had on the other one, it'd been faster. So yeah, it's a lot faster, right? Like it's bam. That's kind of what I was expecting out of VLM. So I don't know what's going on with this VLM test today. So I'm gonna chalk that one up to the strange request here, but
well, and let's call that out because that's not normal. That's not normally what you see when you use VLLM. By the way, I hate saying that term. It always gets me tongue-tied. VLLM.
Yeah. I get it. Now let's do the same question on the Cincinnati here.
Now, did you leave the MCP server up and running on this one? You just moved it over to a Llama?
Oh no, the MCP server just runs on Tanzu platform on CF.
No. I'm with that, but did you leave it bound because you had to? It didn't know. This model didn't know the time until you bound the MCP server. Now it knows. The time.
Yeah, it was
making sure that
bound. Yeah, okay. This is another demo. Yeah, I had laying around here. And interesting. So even on the GPU, like it's either got to be something specific to GPT-OSS, or because it still thinks Central Daylight Time, right? Like it's
All right, time to talk
strange.
to Courtney Page. Hey, do you have something hard set in there that we should know about?
No, I want to do some research to see, is it the model itself? There's something wrong with GPT-OSS where it doesn't know that Cincinnati's in Eastern time zone, right? Or is it something in this MCP server that gets the time? Maybe it's the service that it calls itself. I'm pondering. I got a lot of questions to ask. Got a lot of homework. I'm going to do a lot of deep dive, and I'm going to get back to you because I use this demo all the time, so I need to know. Or I'm gonna have to pick a different city and pretend I live somewhere else. So hey, that's enough. I'm gonna pick some city in the Central Daylight Time, right?
Right.
But yeah, so yeah, that's a quick show. We've got the different flows, and the one big call out to you is if you're gonna run this on Ollama in an air gap, you're gonna want to run the version or the variant of you have to pull a GGUF to get that file air gapped. Don't use the existing GGUS out there on the Hugging Face. Like normally we're like go get an Unsloth or a Bartowski. Those are probably most likely still not going to work because there was like kind of this rift within the core Llama CPP community, right? Because Ollama is essentially like a wrapper on top of Llama CPP, and they worked directly with OpenAI to get day 0 support. So they kind of made their own little branch of this code. And they're starting to roll back into the Llama CPP branch, or like the proper way that they implemented the new MXFP4 format and all that jazz. But it's still not quite compatible with some of these other GGUFs made directly on Llama CPP. So you either pull directly from the Ollama library, or there is a way. And I actually have it on my Hugging Face repo where there's a way, I'll post these links in the show, where you basically query the Ollama library directly in your browser, get a couple things and pull the string and just like download the model file directly out of the Ollama library, like on your computer. And then you just literally simply rename it to .gguf, and then you put it in your file store, your model store, wherever you keep your stuff. And then you pull that directly and then, use that, and it works from there as well. So that's something to keep in mind. But in my Hugging Face repo, I had that. I stored that, and I saved it as a GGUF and the model file I use. So that's kind of all you really need. And I'll probably put a couple more instructions there too, what I did for this model. But yeah, it's running. I think you're going to
need to, because you rapid fired that off at about 4x speed. So
I'm sorry. Well, I know we're like over time, and like it's So basically, if you're doing this, if you're using Ollama and you're using it offline models, I know a lot of people are here. GPT-OSS is still a little needs some special love still, because it's not gonna work directly with your normal GGUS on the same topic, so to speak.
Yep. And I did pull up the mixture of experts architecture, but we're running out of time, and I actually have to go. I'm bumping up against another meeting, but maybe one of the next shows we'll get into the architecture on mixture of experts and have Nick walk us through that. And then I'll go ahead and tell you about some stuff that we heard, because this is all very relevant. Some stuff that I heard at OSS Summit EU, a company by the name of Deep Computing, and the ability that they're bringing in, making AI accessible, much like Project Digits did, but at a much lower cost rate. So we'll talk about that maybe on the next show or the show after as well.
And don't forget to like and subscribe if you're hanging down this long. You should check us out. Thanks for watching.
Yep. And don't forget to join the Slack channel. We're going to keep making this call out. Get on the Slack channel, jump into general. And if there's something y'all want us to talk about, help us out. I'm not going to lie, it's difficult to come up with episodes every single week and keep topics rolling. So get on the Slack channel, get engaged, and let us know what y'all want to talk about.
Exactly.
Yep.
All right. Well, do you have any other closing thoughts?
No, not for me.
Okay. All right. Well, thanks for watching. We'll be back next week with some more great content. And yeah.
All right.
All right. Well, 3, 2, 1.
CF bye.